All right, so we have another question that says, it's a very straightforward question. How much sodium chloride should be used in preparing 100 milliliter of a 1% weight by volume solution of atropine sulfate, which is to be made isotonic with lacrimal fluid? Now, the way the question came, it's supposed to be how much of sodium chloride should be added to 100 ml of 1% weight by volume solution of atropine sulfate so that it will be what? It will be isotonic with what? Lacrimal fluid. In other words, how much of sodium chloride will be added to 100 ml of 1% weight by volume atropine sulfate so that it will have the tonicity of what? 0.52. Is that okay? That is the intent of this particular one. So what are we to do in this case? First of all, let us calculate the mass in gram of 1000 ml of 1% weight by volume of atropine sulfate. 100 ml. Now 1% weight by volume means what? 1% weight by volume. Since it's percentage, it means 1 gram in 100 ml, right? Is that okay? 1 gram in 100 ml. Now, so what we intend to do now, listen, you intend to actually make a solution in such a way that the tonicity will be what? 0.5. Now, what is the tonicity of sodium? What amount of sodium chloride are you going to measure ordinarily? What amount of sodium chloride are you going to measure ordinarily that will give us a tonicity of 0.52? Is it not 0.9? 0.9 now. Percentage what? Weight by volume. Is that okay? This one is also 1% weight by volume, which is equals to 1 gram in 100 milliliter. So it means that the amount of sodium chloride that will actually give us this 0.9%, which is the amount of sodium chloride that will give us 0.5 tonicity, 0.5 to tonicity, 0.9% weight by volume. Now this 0.9% weight by volume, convert it to gram. What will it become? It will what? 0.9 gram. Are you getting it? In how many ml of water? 100 milliliter of water. So what we intend to prepare is a situation where we will measure 0.9 gram of sodium chloride in what? 100 ml of what? Water. But now we have two things that we need to mix together to give us this thing. So most times what we actually do is to assume that everything, because they ask you how much of sodium chloride you need to add to this. Are you getting it? How much of sodium chloride you need to add to this? Now, but you know that this is equals to 1 gram of what? Atropine sulfate. This whole thing you have here is equals to what? 1 gram of what? Atropine sulfate. Are you getting it now? So that at the end of the day, you will now say that 1 plus, which is 1 gram of atropine sulfate. I'm just trying to make it simpler. 1 gram of atropine sulfate plus X, because they ask you to calculate if you add atropine sulfate with what? Sodium what? Chloride. So it's supposed to be 1 gram of atropine sulfate plus S gram of what? Sodium chloride, supposed to give you a total of tonicity of what? 0.52. But now the 0.52 is also equivalent to 0.9 gram. Abi? So you can now say it's equals to 0.9 gram of what? 0.9 gram of sodium what? Chloride. Do you understand now? So 1 gram of this one now is what? Atropine sulfate plus S gram of sodium chloride will give you what? 0.9 gram of what? Sodium chloride, which is what you are looking for. Because 0.9 gram of sodium chloride in 100 milliliter, everything here is already in 100 milliliter, right? In 100 milliliter, we give you what? A tonicity of what? 0.52. Do you get the idea? So that at the end of the day, you are looking for S gram of sodium chloride. This is sodium chloride, this is sodium chloride, but this is what? Atropine sulfate. Are you getting the idea? You cannot use atropine sulfate to subtract sodium chloride. Here have to be what? Sodium chloride too. Do you get the idea? Here have to be what? Sodium chloride. So that it will be sodium chloride plus sodium chloride to give us what? This value. Are you getting it? Now, we will now want to know this 1 gram of atropine sulfate is equals to how many gram of sodium chloride? If we know that value, we'll be able to calculate S gram of sodium chloride that we need to add. Do you get it? This 1 gram of atropine sulfate, we want to know how many the grams in what? Sodium chloride. Are you getting it? What gram does it represent in sodium chloride that will give us when we add it, that will give us this? So 1 gram of atropine sulfate, see, this is how you calculate it. To calculate it, you now say gram equivalent of sodium chloride. That is this thing. Gram equivalent of a compound S, let's just put it like this. 1 gram of any compound, or let's say 1 gram of compound is equals to this formula. The formula we are going to use is the molecular weight of sodium chloride divided by the dissociation factor for sodium chloride times the dissociation factor of that compound divided by what? Molecular weight of that compound. We give you, so 1 gram of the compound is equals to molecular weight of sodium chloride divided by dissociation factor of sodium chloride times dissociation factor of the compound divided by molecular weight of the compound. This will give you the equivalent of sodium chloride. Do you understand? So what this definitely means is that any gram of a compound that is given, 1 gram of any compound given to you at all, is equivalent to this formula of what? Sodium chloride. Are you getting it now? So in this case now, what do you think is now going to be? 1 gram, let me just give some space here. 1 gram will be equal to, what do you think this will now give to us? This particular one. Molecular weight of sodium chloride is what? 58.5. The dissociation constant of sodium chloride, we already calculated it as what? 1.8. Are you getting it? Because sodium chloride dissociates about 1.8 times the dissociation constant of atropine sulfate was given as what? 2.6 divided by molecular weight of atropine sulfate is around 695. So you have 695. Calculate of sodium chloride. So 1 gram of atropine sulfate in this case, are you getting it? Is equals to this gram of what? Sodium chloride. So that will give us, I think, 0.12. Did I give to us 0.12? 0.121, which is approximately 0.12. Is that okay? So what that means is 0.12. What that means is that 1 gram of atropine sulfate that will give us an acetonic solution is equivalent to 0.12 gram of sodium chloride that will give us the same one isotonic solution. Do you get it now? So in place of this 1 gram of atropine sulfate, now what are we going to put there? 0.12 gram of sodium what? Chloride plus S gram of sodium chloride plus what? 0.9 gram of what? I mean, this is equals to what? 0.9 gram of what? Sodium chloride. So to calculate for X, what do we do? To calculate for S, we move this one to this side, Abi, so that X will now be what? So X will now be 0.9 minus 0.12, supposed to be 0.12. So minus 0.12. What did S give to you? 0. What? 0.78. Is that okay? So it means you need to add 0.78 gram of what? Sodium chloride to what? 100 milliliter of 1% atropine sulfate in order to make an isotonic solution. Do you get the idea now? So the way the question came was what was confused. So if you see this question like this, what is the first thing you need to do? Just first of all, understand the concept that they are asking for how many grams of sodium chloride will you add to this amount here, which is 100 ml of what? 1% weight in volume of what? Atropine sulfate. That will give you what? That will give you 0.52 solution. Now, but you know that 0.52 solution is still equivalent to what? 0.9 gram of what? Sodium chloride. Do you get it now? So you are actually looking for the amount of sodium chloride you are going to add. This 100 ml of atropine sulfate, we said it can also be written as what? 100 gram. 1% is also 100 gram in what? 100 ml. 1 gram rather in 100 ml. Right? 1 gram in 100 ml. Now, if it is 1 gram in 100 ml, I've told you that you cannot calculate how much of 1 gram, right, of atropine sulfate is what? Sodium chloride. By using that formula, then you now substitute that in and then get the amount of sodium chloride you need to add. So that is that for this particular one. All right, let's see for the next one. Zinc, these ones are very, very straightforward. Zinc sulfate is a 2-ion electrolyte dissociating 40% in a certain concentration. Calculate its dissociation factor. What did I say dissociation factor is? I said is the number of particles after dissociation. Number after divided by number what? Before dissociation. Now, if it dissociates 40% and it's a 2-ion electrolyte, it means you have zinc sulfate. If zinc sulfate dissociates, what are you going to have? Zinc ion plus what? Sulfate ion, right? Now, if it dissociates 40%, it means 60% did not dissociate. So let us assume the number before is 100 all over. The number after will now be, if only 40 dissociate, it means 60 did not dissociate. And that 40 of zinc sulfate that dissociate will form 40 of zinc ion and 40 of what? Sulfate ion. So 60 plus 40 is what? Plus 40 is what? 140. So 100 divided by 140, what will it give to you? 1.4. So this will be the dissociation constant factor. So that is how to solve for this one. Now the next one is, okay, this is still the same question. Zinc chloride is a 3-ion electrolyte dissociating 80% in a certain concentration. Calculate its dissociation factor. Say dissociation factor is number of particles after divided by number of particles before what? Dissociation. Now, zinc chloride, when it dissociates, is going to form zinc ion plus 2 chlorine ion for the equation to be balanced, because you can see 2 chloride ion here, right? Now, if you look at this very well, how many zinc ion are here? 1. How many chloride? 2. 2 plus 1, 3. So total ion here is how many? 3. Do you get the idea now? So if we have total ion here to be 3, so what is the number of particles? For 80% dissociation, Abi. So it means undissociated particle will be how many? 20. If we say number of particles before dissociation is what? 100. Before the particles that did not dissociate will be what? 20. Right? 80 will be for this ion. 80 will be for this ion. 80 plus 8 is 160. Plus 20 is what? 180. Abi? Now, no, the 2 will affect this one. So when the 2 affect this one, it becomes, because you have 2 of the chloride ion, which is still the same thing as chloride ion plus what? Chloride ion. So here will still be 80 of one chloride, 80 of the other chloride. So this one now will now be 80 plus 80 plus 80, that is 240 plus 20. That will give us 260, right? So 260 divided by 100, what would that give to us? 2.6. So that is how to calculate your dissociation constant for any ion given to you at all. Now, papaverine hydrochloride molecular weight. The molecular weight was given as 376. It's a 2-ion electrolyte dissociating 80% in a given concentration. Calculate its sodium chloride equivalent. So, it's a 2-ion electrolyte. Now, if they say it's a 2-ion electrolyte, it means, let's say, papaverine hydrochloride, let's just assume, it dissociates into papaverine and what? Hydrochloride. If it dissociates 80% in water, in solution, so this one will be what? 20, here will be what? 80, here will be what? 80. So what do you think is the dissociation constant? Dissociation constant and factor will be what? If 100 we are in solution before, dissociation factor will be 100, then here will be what? 180, which is equals to what? 1.8. Is that okay? So that will be 1.8 for the dissociation factor. So we have our I to be 1.8. So I is 1.8. Calculate the sodium chloride equivalent. I've told you how to calculate the sodium chloride equivalent. What is the molecular weight of sodium chloride? 58.5. So this one is 58.5. What is the dissociation constant for sodium chloride? It's still 1.8. Because that is like the standard they use. Sodium chloride dissociates about 80% in a given concentration. Now, almost all other things dissociate, apart from those of zinc that dissociate about 40%. All right. So, what was the formula I earlier gave for calculating this? I said 1 gram of any compound, in this case is what? Papaverine what? Hydrochloride. Right? Let's use pH. Is equals to what? Molecular weight of sodium chloride divided by what? Dissociation factor for what? Sodium chloride times what? Dissociation factor for the compound, in this case papaverine, divided by what? Molecular weight of what? Papaverine hydrochloride. So 1 gram of papaverine hydrochloride is equals to this amount of what? Sodium chloride. So this case now it will be 1 gram, that is the gram equivalent of papaverine hydrochloride. That is why I use pH. Molecular weight of sodium chloride is 58.5 divided by dissociation factor is 1.8 times this one will also be 1.8 divided by 376 sodium chloride. Right? Yes, now. So what do you think this is going to give to us? 0.155. So 1 gram of papaverine hydrochloride is equals to what? 0. What? 0.155. Right? Yeah. 0.155. Is there any other? Can we approximate to 0.156? Yeah, 0.156. So 1 gram of papaverine hydrochloride is equivalent to what? 0.156 gram of what? Sodium chloride. So wherever you see 1 gram of papaverine, you can put in what? 0.156 gram of sodium chloride. That was what we did for the last question. Is that okay? Yeah. So that is the sodium chloride equivalent. That is the formula for calculating it. Now let's see for the next one. Calculate the sodium chloride equivalent for glycerin, a non-electrolyte with a molecular weight. Now for non-electrolyte, their factor, dissociation factor is what? 1. Why? Because the number of particles still what? Remains. Are you getting it now? So dissociated all over undissociated will be what? 100 over total number of particles after dissociation divided by total number of particles before dissociation will be 100 over 100 because there's no dissociation, which will give us what? 1. All right. Calculate the equivalent of this. So 1 gram of glycerin, right, will be equivalent to what? To molecular weight of what? Sodium chloride. Are you getting it? Divided by the factor times the factor for glycerin divided by molecular weight of what? Glycerin. So 1 gram of glycerin, that is the sodium chloride equivalent of glycerin, is equals to molecular weight of this is what? 58.5. This is what? 1.8 abi, times 1 divided by what? 92.2 sodium chloride. So the sodium chloride equivalent now will be what? 1 gram of glycerin is equivalent to what? 0. What? 35 of what? Sodium chloride. That's why they call it sodium chloride equivalent of 1 gram of that compound. So when you are reading the material, you see sodium chloride equivalent of that compound. So 1 gram of the glycerin of that compound is equals to 0.35 of what? Sodium chloride. Do you understand now? So that is that. Now, the next one is an assignment. Calculate the sodium chloride equivalent for fluorescein sodium, which dissociates into 3 ions and has a molecular weight of this. It dissociates into 3 ions. Now, if it dissociates into 3 ions, what does that tell you? They gave the I factor as what? 2.6, right? So what do you think the gram equivalent would be? So you can say 1 gram of what? Or you can just write gram equivalent of sodium chloride, right? You know, but I like expressing it that way so that you know that this is what you are doing. So you can say 1 gram of fluorescein sodium is equals to, we already know the formula, molecular weight of what? Sodium chloride, which is what? 58.5. Factor of sodium chloride is what? 1.8 times this case is what? 2.6 divided by what? 376.2 of sodium chloride. That is the sodium chloride equivalent. So in this case, you can say sodium chloride equivalent would be equals to, calculate. What would that give to you? 0.225. So that is the sodium chloride equivalent of what? Of fluorescein. So 1 gram of sodium chloride, 1 gram of fluorescein is equivalent to what? 0.225 gram of sodium chloride. Is that okay? Yeah. So wherever you need, let's say 2 gram of fluorescein, and what you have there is sodium chloride, what you just need to do is use 2 to multiply what? 0.225. Are you getting the idea now? So just that, like that. That's question number 8. Now the next one is calculate the sodium chloride equivalent for timolol malate, which dissociates into 2 ions and have molecular weight. Now, sodium chloride equivalent will be what? For this case, mass of sodium chloride, which is 58.5 divided by 1.8 times what? 1.8, that is the factor, is correct, divided by 432.2. What will that give to you? Of course, you know you are going to write the formula out in the exam and the rest.
0.135.
0.135. Can it be approximated to 0.136? Is it possible? Okay, 0.135. Yeah, the answer they got here is 0.136, but it's also very close. Maybe approximation issues. All right, so that is that for this question. Now, no, this is a different question. Now, we are back to dispensing. How many grams of sodium chloride should be used in compounding the following prescription? Prescription, you are giving pilocarpine nitrate, 0.3 gram. Sodium chloride, add as much as you want. Purified water to 30 ml. Make isotonic solution and then give for the eye. Now, it's an ophthalmic solution, of course, so it will have a tonicity of what? 0. What? 52. which is equivalent to how many gram, which is equivalent to 0.9% weight in volume of what? Sodium chloride. Abi? Now, how many things are you using for this preparation? You are using pilocarpine, nitrate, right? And what? Sodium chloride. You are looking for amount of sodium chloride you have to add. Abi? So can we now say sodium chloride, amount of sodium chloride, right? Chloride plus the amount of pilocarpine nitrate should be equals to normal saline, which is the same thing as what? The tonicity that you need. Normal saline is what? 0.9 gram in what? 100 mil. Are you getting it? Which is 0.9 gram. Now, but this case, you are not using 100 mil. They gave you in what? 30 mil. You get it? So what we are to work with now is the values here in what? 30 mil. That is equivalent. Are you getting it? Yeah. To standard normal saline. So you are now going to say, look, you are now going to say 0.9 gram is equivalent to what? 100 mil. Yes. Right? Yes. Of normal saline. But now they didn't give you, the solution you are preparing is not in 100 mil, it's in 30 mil. So you have to make everything to be what? 30 mil. So sodium chloride plus this will give you that amount in what? 30 mil. Are you getting it now? So 0.9 gram will be equals to 100 mil. Then 30 mil will be equals to what? X. So you now say total amount of this thing, sodium chloride needed in 30 mil. That's what we are calculating. Yeah. So X now will be 100x will be what? 0.9 times 30. So divide both sides by 100. What did you get?
0.27.
0. What? 27. So it now means that your X is what? 0.27 gram in how many mil? 30 mil. So since the solution is a 30 mil, we can now say sodium chloride plus this will give us what? 0.27 gram in what? 30 mil. Now, do you agree with me that this 0.27 in 30 mil is still the same as normal saline? Yeah. Are you getting it now? But what you only did was to what? Reduce the concentration and then reduce the what? Volume. But it's still equivalent to what? The tonicity we need, which is the one that will give a depression of what? 0.52. Do you get it now? So that is what we actually did there. 0.27 in 30 mil. Now, sodium chloride, what you are looking for is how much sodium chloride are you going to add plus what? Pilocarpine, right? Nitrate that will give you this. All right, but we don't know sodium chloride. We don't know pilocarpine nitrate. But if we are able to get the gram equivalent of pilocarpine nitrate, we will be able to calculate for that of sodium chloride, because what you have here is what? Sodium what? Chloride. Abi? What you have here is also sodium chloride. So we should convert this pilocarpine to what? Sodium chloride. How do we convert it from what we did initially? What do we say? We say gram equivalent of pilocarpine in sodium chloride will be the what? The mass of sodium chloride factor times molecular mass of pilocarpine times the what? The factor. Divide by the factor. But in this case, if you look at this question, give the gram equivalent to be what? 0.23. So it means that 1 gram, it will be given. If it is not given, parameters for calculating it will be given in the exam. So it means 1 gram of pilocarpine nitrate is equal to what? 0.23 sodium what? Chloride. Right? Therefore, what was the gram? Because what you are looking for now is not, you are not substituting 1 gram in. What they gave to you for pilocarpine nitrate is what? 0.3 gram. Do you get it now? So you must convert this 0.3 gram of pilocarpine nitrate to what? Sodium chloride. But we know that 1 gram of pilocarpine nitrate is equals to what? 0.23 gram of what? Sodium chloride. Do you get the concept? So if you already know this, it means our 0.23, I mean 0.3 now will be equals to what?